And remember not to fall behind, because then it's going to pile up and it's going to be very difficult to catch up. 52. 52. Where are you, 52? Okay, I see it. X to 2/5 plus x to 1/5 minus 6 equals 0. And you could say, wait a minute, you're going back to those equations with fractional exponents. No, not really. But it looks like it, definitely. I'm really hoping that it's quadratic in form, and I'm really hoping to change it into the quadratic equation. If that is the case, which of these two powers is the smallest? I don't know if it works, but which one is smallest? 1/5. So I'm going to say let t be x to 1/5. But this will work only this is what? Only if this is right, but let's see if it is t squared. If I square this, I get t squared. If I square this, I get x to 1/5 everything squared. What does this equal to? X to which power? 1/5. What is the operation? Multiplication. Very good. 1/5 times 2/1. How much is that? Right. So is this t squared? Yes, it is. So can anyone dictate the new equation, please? Awesome. Now, I hope you agree that this is more human than this one, isn't it? And this is even easier on the eye than that one. Okay, so now what type of equation is this? It's quadratic, which means this equation, although it appears to be with fractional exponents, which it is, I shouldn't say appears, it's actually much easier than that. It's a quadratic equation. I mean, it's quadratic in form. It can be replaced easily. It can be replaced by a quadratic equation. This I know how to handle. How? Good. So then I have t minus 3 will not work with positive 1. So t minus 2, t plus 3, and let's see what we get for t. And again, you can say, who cares about your t? We do. So t equals
2.
or? Good. What equation is this? T equals 2. Very good. X to 1/5 equals? What equation is this? Equals? You understand, all we did was we replaced t. T is this. So we just have to replace it. Now, what type of equation is this? It's the 5th root of x. So it's radical if you want to say. No, it's an equation with fractional exponent. That is fine too. So then what do I do to both sides? Raise it to? Very good. Awesome. Perfect. So this is x, and the right-hand side is?
32.
Awesome. And I take both sides to the 5th power, and this is x, and this is?
243.
Negative 243. I agree. It comes with a question mark, right? Because I raised both sides to the 5th power. Well, I have to be honest and tell you this. Every time we raise both sides, as you remember, both sides to a power, 2, 3, 4, 5, 6, and remember we have to check in the original problem. But when the power is odd, everything will work, no matter what. When the power is even, it may not. So I still have to show my professor, then I say, I'll check. Yes. Yes and yes. They will both work because the power was 5, an odd power. Okay, good. Any questions about substitution or quadratic in form? Equations quadratic in form. We think we need another where we can move on to the last type. Do we need another of quadratic in form? Very good. Okay, so let's look at 57 on the same page. Don't be shy. Please let me know what you need. Otherwise, I will not know. First of all, I'm going to ask myself what type of equation is this, and I will say it's polynomial. When I square x squared, what do I get? Good, so it's polynomial. What is the degree? How many solutions? However, let's look again. Is this equation quadratic in form? Is there a substitution that will help? Say it again. I just couldn't hear.
I was gonna say, could you move 24?
I would never do that. If it's quadratic in form, I need 0 on the other side. If I need to square and so on and so forth, I need 0 on one side. No, I don't really want to. Okay, so which power is the smallest? There is a power here and there is a power here. Which one is the smallest? 1. So I'm going to say let t be x squared minus x. And let's see if it works. I don't know. As long as this is, you want y? That's fine. But we cannot use y and t. Good. Y squared. Is it? Is this y squared? If this is y, is this y squared? Good. So now can anyone dictate the new equation? Perfect. What type of equation is this? So then what type of equation, other than polynomial, which we know, what type of equation is that one then? In form. Perfect. Awesome. So I'm hoping that this does not take long to factor. If not, I use the quadratic formula. Good. So there are two options. Very good. So what equation is this? See, the first equation took us 5 minutes, and then the subsequent ones, it took us a minute and a half to 2. And what equation is this? Do you agree with these two new equations? What are they? What type? Quadratic. How many solutions will I get from each? So 2 from here, 2 from here. How many solutions I expect total? Good. Perfect. How do I solve a quadratic equation like this one? Very good. I have to have 0 on one side. If factoring takes too long, then quadratic formula. So what do I do next? Good. The product is -2. The sum is -1. Very good. Do you all agree? So there are two options for x. And they are? Do we accept? Any questions? Any questions for me? Okay, so let's look at the last one. Again, x squared minus x minus 12 equals 0. We hope that this is also easy to factor. Let's see what we get. Very good. And x minus 4x plus 3. So the options are, and we got our 4 solutions. Equations quadratic in form could get slightly difficult, but they're not such a big deal, I would say. The last type of equation is number 5, I believe, absolute value. Absolute value equations. Let me start with a very simple example, and then we select from the book. The absolute value of x equals 3. So what is this equation asking us? If you remember, the absolute value of x is the distance between x and 0. So this equation says, find those numbers whose distance from x and distance from 0 is exactly 3 units. 3 units this way, 3 units this way. -3 and 3. Perfect. That's the answer. So there are two options here. In here, I can have 3, and the absolute value of 3 is 3. Or I can have -3, and the absolute value of -3 is 3. So x equals 3, or x equals -3. All I have to do now is mimic this concept for any problem. So here is the first one. Let's say 68 on page 186, and that is 3 times 2x minus 1 equals 21. A note before we start. The absolute value symbol is not a grouping symbol. Meaning, you cannot distribute inside. You cannot move one to the other side. This is untouchable. You cannot break it. You cannot do anything to it. So my first question is, what type of equation is it? Absolute value. My second question is, like always, can I clean it up? Can I simplify it? Yeah. Dividing both sides by? Good, awesome. What is left on the left-hand side? The absolute value of 2x minus 1. What is left on the right-hand side? 7. Good. Now I'm finally back to this setup. And I'm asking myself, what can I put in here so that the absolute value of those numbers or number is 7? What could this be?
4.
Well, 4, the absolute value of 4 is not 7. -7, this could be -7, and what else? And 7. So there are two options. I cannot, do not do that like I do it. I cannot solve this. I don't know how if I don't replace this equation by two different equations. So what is the first one that you just told me? The equation. You're right.
2x minus 1 equals 7, and then 2x minus 1 equals 7.
Perfect. Do we agree with this? Because this quantity can be 7, and this quantity can be -7. Agreed?
Yeah.
So I add 1 and divide by 2, and I get x equals 4. I add 1 and divide by 2, and I get x equals -3. One more time. I add 1 and I get 8. Divided by 2 is 4. I add 1, and I get -6. Divided by 2, -3. Any questions? Let's choose another. Yes? One more? Okay, perfect. Let's say 71 on 186. 2, the absolute value of 4 minus 5 halves x plus 6 equals 18. What type of equation is this? Very good. Can I clean it up? Can I simplify it somehow? Perfect. What will be my first step towards simplifying it? Very good. So 2, the absolute value of 4 minus 5 halves x equals 12. Perfect. Can I still simplify it? Divide both sides by 2. 4 minus 5 halves x equals 6. I don't know how to continue. This means nothing if I don't know how to change it into 2 equivalent equations. 2 equations replace this one. So I'm ready to write the equations. 4. Very good. Equals? Awesome. And 4 minus 5 halves x equals? Awesome. Perfect. That's all I needed. So then, how do I solve the first equation? How do I solve the second one? But first I have to ask myself, what are they? They could be quadratic. They could be quadratic in form. They could be rational. They could be polynomial. They could be with rational exponents. They could be radical. They could be so many different. Linear. Linear. They are linear equations. Perfect. 4 minus 5 halves x equals negative 6. What is the first step? Subtract? 4. Awesome. So negative 5 halves x equals negative 10. Perfect. Now, my target is to eliminate what? Negative 5 halves. I want this to go away. So I will multiply both sides by negative 2 over 5. You can do it in 2 steps. I'm fine. I would like to do it in 1 step. It's up to you if you want to do 2 steps. So if I want to eliminate negative 5 halves, I need to multiply by the multiplicative inverse. Multiplicative inverse, negative 2/5. The left-hand side is definitely awesome. The right-hand side, I multiply 2 negative numbers. 10 times 2 over 5. Right? Because I simplify 5 and it's 4. Or say 10 times 2 is 20 divided by 5 is 4. I still have one other equation. So 4 minus 5 halves x equals 6. First step, like you just said, subtract 4. Good. Same step again. I want to eliminate negative 5 halves. What should I do to both sides to eliminate negative 5 halves? Negative 2/5. Very good. And negative 2/5. The left-hand side is definitely what I wanted it to be. Very good. And the right-hand side is, first of all, it's a positive or a negative number? Very good. 2 times 2 over 1 times 5. There are 4 types of absolute value equations of this type. So 1 is with no solutions. The second type is 1 solution. The third type is 2 solutions. And the fourth type is infinitely many solutions. We only had examples from this one. In all situations that we looked at, there were 2 solutions. Let me show you the other types. So here I have the absolute value of x equals negative 3. What type of number can this be? The absolute value is always what type of number? Good. What type of number is this? So what do you say if I come to you and I say 15 equals negative 3?
No solution.
Exactly. This is this type. No solutions. Let me give an example from this type. The absolute value of x equals 0. How many options are there? Yes. X must be? That's it. So this is this type. And here's this, the last one. However, I will not test you on the last one because I need 2 absolute values. And I don't see any problem with 2 absolute values in your in your book. Or I couldn't find them. So anyway, so let's say x plus 1 equals the absolute value of 1 plus x. Okay, first option is x plus 1 equals 1 plus x. And the second option is x plus 1 equals the opposite of 1 plus x. You don't even have to write this because I'm not going to test you on this. So from here, x equals x or 0 equals 0, infinitely many solutions. Here, even if I distribute, I only get one solution, x plus 1, negative 1 minus x. That's going to be 2x equals 2, negative 2, so x equals negative 1, but negative 1 is already in there. You don't need to do anything with that. Would you like another absolute value equation, or I still have 9 minutes? I'd like to start something. Another equation, another absolute value? Okay, so let's look at another absolute value equation. I just turned my page. So yes, let's say 75. The absolute value of 2x minus 1 plus 6, no, I'm sorry, plus 3 equals 3. Okay, what type of equation is this? Very good, it's an absolute value equation. What would be the first step? Very good, so this is 2x minus 1 equals 0.
Is that a 3?
Yes, I'm sorry. Good. So then, from here, how many options are there? Yes, only 2x minus 1 equals? That's it. Linear equation, move 1, divide by 2. Okay, so this is an example in which there is only one solution. Okay. The last section of the review of chapter 1 is inequalities. We will not be able to finish this today, but at least let's look at one inequality, and then we can stop. If we have time, we'll do 2. Okay, so let's say problem 46 on page 203. 4x minus 3 divided by 6 plus 2 is greater than or equal to 2x minus 1 divided by 12. First, I know it's an inequality, but what type? Only if the denominator has x in it. But since no denominator has x in it, it cannot be rational. It is linear. Very good. So this is a linear inequality. That's what I heard, so that's what I said. If you said something else, it's fine. Okay. There's one thing I don't like about it. And you will say, we don't like. Good. However, they're very friendly, really. We can get rid of them very easily. How? How will I get rid of fractions in this? The least common denominator. I see 3 denominators. 6, 1, and 12. And the least common denominator is? 12 is the least common denominator. Because they're fractions, please, I encourage you to write this. 12 over 1. This is okay because the denominator is 1. And then 12 over 1 because we need to simplify first before we multiply. So I will simplify 6 and 12 by? I will simplify 6 and 12 by 6. 6 divided by 6 is 1, and 12 divided by 6 is 2. Can anyone dictate the first quantity that I have to write?
8x minus
Perfect, you're right. I'm going to write it like this for now for everyone to see. Do you all agree with the first quantity? Then I have 2 times 12. What will you say? Plus? Good, very good. Greater than or equal to Simplify before you do anything. 12 divided by 12 is 1. 12 divided by 12 is 1. What do I have on the right-hand side?
2x-4.
Good. So now this is definitely more human than the original one. It wasn't that difficult to eliminate fractions. We multiplied by, we found the least common denominator, we multiplied, it's done. Now, yes, you already told me to distribute. So this is 8x minus 6 plus 24 greater than or equal to 2x minus 1. I will completely simplify both sides before decide to move terms around. So this is already simplified, this is not. I will only say 8x plus 18 greater than or equal to 2x minus 1. And now, yes, I will move 2x and I will move 18. When I move 2x to the left-hand side, I get, very good. When I move 18 to the other side, I get, awesome. Finally, I divide both sides by, good, negative 19 sixths. We need to discuss the interval notation. I caution you that my math lab will require the set builder notation sometimes. So we'll talk about that. So the interval notation, I will present the real line. No units are necessary here. 0 is in the middle. This number is a little bit to the left of negative 3. Negative 18 over 6 is negative 3, so it's a little bit left. So somewhere here. I don't care for units. 19 over 6. Say it again. Oh, I'm so sorry. Forgive me. Sorry. So now, which direction am I going into for this? To the right, with a bracket. Why a bracket? Because of the equal symbol. Bracket. Yes, it's a full circle, if you want to use that. But this is the interval notation, and I write x is a number in the interval, bracket, negative 19, 6, comma, infinite. So this is the interval notation. The set builder notation, and I will stop right now, just in case. Set builder notation. I don't use it. I'm not going to ask you to use it, but my math lab will. Set builder notation for this solution is x. So it's the set of numbers called x. This vertical bar stands for such as or for with the property or having the property of this. So this is, to me, not useful. I'm just copying this here and I put 2 braces in the bar. I'm not saying anything else. So this is the end of the inequality, and then I just copy it here. For me, this is not useful, but this is useful, the interval notation. So this is called the interval notation. If we have the equal symbol, we have to put a bracket. If we did not have the equal symbol, it would have been a parenthesis.